let's continue our theme of looking at different mechanistic steps by examining coordination, which is another way of saying a bond forming step. Now, these are particularly small, quick steps, so let's just look at what this entails. It's mainly just two species coming together, making a new bond. So let's look at this. We start off with, say, a carbocation. So a positive charge on that carbon is tertiary. This is got an incomplete octet. And so we'll probably want to coordinate with something or make a new bond so that we can satisfy this octet. So this should be fairly reactive. Now, if we have some species, such as a bromine, or bromide, I should say, this is a negative charge, then these two could associate with each other. And so this negative charge with a single arrow associates there, and then we can form this product. Now, this is really just a Lewis acid. And this is really just a Lewis base, right? But we could also think about this, and this is a Lewis adduct. All right, so that's one way to think about this. Another way to think about this is a nucleophile. This is an electrophile. So just depending on what makes the most sense or what the conditions are, we may think about this as being a Lewis base, or we may think about it as a nucleophile. And here we may think about this as a Lewis acid or an electrophile, something that wants electrons. Certainly a carbon with a positive charge on it is wanting some electrons. And here we have something that has electrons, so it can coordinate with it. So simply just a negative charge approaching a positive charge. Now, this does not need to happen with a positive charge and a negative charge associated with each other. Coordination can happen between uncharged species as well. So let's look at that. So we have our acid chloride, and these have, chlorides have lots of lone pairs around them. So this could be fairly reactive there. And then we have an aluminum chloride, let's say. Now, the aluminum has space for more electrons because it only has 3 bonds around it. Now, this is okay because aluminum, it sits right under boron, and as we know, boron can have 3 bonds to it and be perfectly fine. But we also have negative charges being pulled, or the electrons being pulled by these electronegative atoms around it, the chlorides. And so this will have a partial positive charge on it, and the chloride is relatively reactive, so this can have a little bit of a partial negative there. And we can have a coordination step here. So this can coordinate with the aluminum. Draw the double-headed arrow. And in this case, this step is reversible. So let's see here, L. And we're going to have a formal negative charge on aluminum. right? We'll have a formal positive charge on the chlorine in this structure, right? Because we're using the 2 electrons from the chlorine to bond to the aluminum right here. And so, yes, formal charge of negative here, formal charge of positive there. But this is coordination, and it is an elementary step that we'll see in organic mechanisms, especially when we're talking about a substitution nucleophilic unimolecular, which this is kind of the part of that. And we'll discuss that more later, but coordination is an important step in that process.